Okay, so here we have compound inequalities, which is chapter 3, section 6. My objective here is I want to solve and graph compound inequalities in one variable. So what I would like to do here is, let's first off go over what is a compound inequality. On a compound inequality, what we want to see here is, let's look at an example. There's two types. There's ands and ors. The first one I'm going to show you is an and. Okay, and I'm going to show you three graphs. The first two are like the left and the right that I have here, x greater than 2, and then the second one will be x less than 6. And then the third one is the actual compound inequality graph, how you graph it. Ands usually end up like this. Now there will be some exceptions. I'm not going to show them to you here. Maybe you'll see them in Algebra 2, so don't worry too much about that. But let's look at this. Okay, so I'm going to put 2 and 6 on all of these. X greater than 2 would be an open dot shaded to the right. X less than 6 would be an open dot at 6 shaded to the left. And worries about where do these two overlap. And if you look, these two overlap here in the middle between 2 and 6. So since that's where they overlap, that's what I would graph. That is x is less than, or is greater than 2 but less than 6. Another way to write that is like this. X is between 2 and 6. And statements usually will be between. Okay? So now let's look at or. Or is the other one. So x is less than 2 or x is greater than 6. And again, I'll do 3 to show you. The final one is your final answer. You're going to start doing these with just that one graph that you see at the end. I'm just showing you the reasoning why. Okay, so you can see here, x less than 2, shaded to the left, put an open dot. X greater than 6, open dot, shaded to the right. Or, I don't care, it's two graphs in one. So basically, I just copy those two down. They don't have to overlap. So ors are like that. And usually ors do go in separate directions. Okay. There are, again, exceptions to that rule, but not too often. All right, so let's look at an example of, say, an and statement as a problem. Okay, they didn't give me one where it was like something and, but this is an and statement. This is how and statements normally going to work. And you work from the middle. Like say, like if you were to ignore that 4, you would just say, well, I'm going to do 8 minus 2 because the opposite of adding 2. Working from the middle, working with what's inside, what's right there with the x, is going to be subtract 2. Well, whatever you do to the right, 8 minus 2, then you should do on the left side, 4 minus 2. And you get an answer of 2 is less than or equal to x, which is less than 6, which means 2 is between, I'm sorry, x is between 2 and 6. Notice the answer is in, like the x is in the middle of 2 and 6. So that means your graph is in the middle of 2 and 6. Fairly simple. Let's look at another example, because sometimes this one is the one that gets people. Not the ors, but the ands. So let's look at another one. Negative 5 less than 2x plus 3 less than 9. Now, some of y'all are forgetting that I got here. I still get people telling me, what do I do first? Guys, you've been doing this now for 2 or 3 weeks. They're the same problems. You see a plus 3. What's the opposite of a plus 3? Minus 3. And whatever, again, you're doing. Again, working from the middle. Working from the middle. Look at the x. What's being done to the x? Okay, so if I'm going to subtract 3 from the 9, I got to do it also on the 5. I'm sorry, negative 5. So that gives me negative 8. With a 2x in the middle, negative 8, and a 6. Then I'm going to divide by 2, everything by 2. That gives me negative 4, x is between negative 4 and 3. Put my points, close dot on the 4, open dot on the 3. Negative 4 is closed dot, 3 is open dot, because notice the different signs. Then shade in between. That's it, you're done. The key point there is you're working from the middle. You will say, look in the middle, and say add or subtract, then multiply or divide. I don't think we'll get much harder than that. Okay, let's look at an or statement. 2x is less than 6 or 3x is greater than 12. Okay, just divide. You got x is less than 3 or divide by 3 here on the other one. X is greater than 4. Look, this one is like two equations with one graph, or two answers with one graph. So I'm going to put 3 and 4 on the number line. Notice again, the smallest number is always on the left. The biggest number is always on the right. Close dot for both, and then just shade in opposite directions. Like I said, ORs usually will shade in the opposite directions. Okay, here's my last set of examples. I want you to write the compound inequality. What compound inequality would fit this? Well, according to this, it's x is less than -1. Notice these are in separate directions, so I'm going to write these as two separate things. And then I also have x greater than or equal to 7. Now, how do I join these? Well, they're going separate directions, so I'm going to say OR. There's my answer. Look at another example. On this one, notice they're joined. The answer is in between 0 and 6, because remember, that shade means that's answers. Those are answers. Those are solutions. So here, I would go ahead and write it like this. X, put those arrows like that. I'm putting no line underneath because they're open dots. This is what you should always put. If you see it in between, it should be like this, with the arrows pointing to the left. Do not forget that. So x is between what two numbers? Well, 0 and 6. You're done. That's an AND statement because you're saying x is greater than 0 and at the same time less than 6. That's compound inequalities. If you do have any questions on this, let me know before you take the quiz later on. Thank you very much.